All right, so in this video, we're going to look at a rational expression. And I've chosen a relatively simple one, but it will illustrate the process that we have to go through and the tricks that have to be applied, if you want to call them that. All right, so our original function is 1 over x minus 3, and we want to show that the derivative is negative 1 over x minus 3 quantity squared. All right, so our original function, we are going to have a little bit of simplifying to do in our initial numerator. And so not as much as when we had the quadratic, but nonetheless. So we're going to keep this out of the final fraction just for a second. And we're going to do a little bit of simplifying on the numerator before we put everything together in our limit. Now for the numerator, the original function, okay, so also remember that f of x plus h, it's not just the function plus h. Everywhere there's an x, we have to replace x with x plus h. So the first term becomes x plus h minus 3, all of that in the denominator, and then the second expression is just the original function. Now, again, we run into a similar problem here where we want to be able to combine and simplify and cancel h's eventually, and that's not entirely clear how that can happen initially. But what we're going to do is we're going to do what we normally do for fractions when we want to add and subtract them. We're going to find a common denominator. Now, the common denominator is just going to be the product of the two denominators we already have. And so this expression is going to get multiplied by x minus 3 over x minus 3. And this expression is going to get multiplied by x plus h minus 3 over x plus h minus 3. Again, we're multiplying by 1 essentially, but that's going to give us a common denominator, and we're going to get stuff in the numerator that then we will be able to cancel. And so when we do that multiplication, we're going to end up with x minus 3. And then in the denominator, we will have two factors, x plus h minus 3 and x minus 3. And again, as I noted in the sort of radical video, do not distribute this denominator. You will just make your life more complicated. You want things to be able to cancel eventually. You want to leave them in factored form. And then what we're going to do is we're going to end up with, again, be careful of the parentheses here. X minus 3, good, minus, but then when you're subtracting a fraction, you're subtracting every term in the numerator, so you need that extra set of parentheses, which we will then simplify later. And again, leave the denominator as it is. Again, this is just the numerator that we're working with here. We actually haven't put everything into the definition yet. And then when we distribute x minus 3 minus x minus h plus 3, x plus h minus 3, x minus 3. Now we can cancel, and notice our minus 3 here, and cancels with our plus 3. This is where everything, again, everything in the original expression has to cancel. And everything that is left, regardless of how complicated the expression is, everything that is left has to include only h. Even if we didn't have x minus 3, we had some crazy polynomial expression. Everything has to cancel except terms that have h in them. And what we're left with is minus h over x plus 3, x plus h minus 3, x minus 3. Now, that is just the numerator. So now what we're going to do is we're going to go back to our limit definition. And we're going to put everything together. This is our limit definition. And so this is going to be equal to this numerator is this thing. Now, I don't find this particular version of this expression to be terribly useful. And so I'm going to suggest an alternative way of expressing this. And that is by actually taking out this 1 over h and then multiplying it by our numerator. Now this is completely equivalent. If I have something divided by h, that's the same thing as multiplying it by its reciprocal, which is 1 over h. But it is a much easier expression to look at because now it is really clear to see that this h right here and this h right here are going to cancel with each other. Canceling. And so now when I substitute in my 0 for h, all I'm left with is this expression. Actually, let me not skip that step quite so quickly. This whole thing cancels. This thing becomes a 1. And then, after it cancels, then I can substitute my 0 in for h. And that will make this. And if I rewrite this, then I get my minus 1 over x minus 3 squared as expected. So again, the idea here for the rational functions is that you're going to need to find a common denominator. That will allow you to do the simplification. You still have to cancel at some point. Everything in the numerator is going to have to reduce to just terms that include h so that you can cancel the h out in the denominator. And then you just finish simplifying after you plug in h equals 0. If you have a combination of rational and radical functions, then you're going to end up needing to do both of those tricks, both the rationalizing the numerator and finding a common denominator. So just be aware, it can actually be more complicated than this, but usually most textbooks for standard homework problems really don't expect you to do much. This is sort of the typical level. It's about as hard as most instructors will require you to be able to do. There are exceptions, but if you have a sort of 1 over radical something or other, you basically do both tricks. You find the common denominator, and then after you've simplified your fraction into something like this, then you do your rationalizing in order to get rid of the h all together.